everyone, I'm Rashmi Nagpal. I'm a software engineer by profession and a researcher by passion. So this is my first time presenting here at React Miami conference. I am a bit nervous, but at the same time looking forward to share my learnings with all of you. So the topic which I'm going to talk about today is build your machine learning model on Edge with React Native. Without a further ado, let's get started. The agenda of the talk is, firstly, I'll talk about why this topic is the need of the hour. Then we'll cover about the basics of machine learning and the edge computing to bring all of us on the same page. Then there is an application demo, which I'll be demoing, and also the what are the use cases possible from the machine learning on the edge devices. And towards the end of the talk, we'll discuss about what are the challenges that we can face. And further on, there is a summarization and a bunch of resources for your future reference. So let's get started. Imagine that you have trained an incredible machine learning model whose accuracy outperforms your wildest dreams. Now, you are ready to deploy that model into production to make it accessible for your end users. So, the logical next step for you is to package the model up and to deploy it using any of the existing managed cloud services, either AWS or GCP. However, you are in the state of shock when you see the cloud deployment bills. It's $20 million. That's big. To support the story with real-time statistics, as you can see on the screen, on the left-hand side, companies like Asana and the Datadog, they invest like half of their revenue on the cloud. And the graph on the right-hand side shows that the companies like the Pinterest, Capital One, they are increasingly investing in the cloud. Now, because of the rising price in the cloud in itself, more and more companies are looking to the ways to shift their computations on the edge devices. And that's where edge computing comes into the picture. Also, in 2022 alone, approximately $490 billion have been invested on the cloud computing, and out of which 30% was wasted, which is approximately $197 billion have been wasted. So these are big numbers. Let's see how the edge computing comes into the picture. But first of all, what exactly is edge computing? So edge computing, according to the Wikipedia resources, state that it refers to the distributed computing paradigm wherein the computing resources are placed closer to the edge devices, thus providing faster response time, lower latency, and of course, reduced cost. But wait, how does edge computing help in this case? So cost reduction. When you are deploying machine learning models on the cloud, you need to get the data back and forth from the cloud, which implies you have to do some real-time prediction, and also for the data-driven decisions, you need stable internet connectivity. What if that's not available? So when you are building machine learning on the cloud, and if you are handling the user-sensitive information or personal identified information, then it also could raise the concerns of the security and privacy. Next, so if you're also running machine learning on the cloud and handling, again, the user-sensitive information or just getting the data from the cloud in itself, then it also, again, does lead to the concerns of the security and privacy, but it also leads to the concerns of the reliability. And also, if you are building models, and if your models are deployed on the edge devices, then it's okay to have a lower inference latency than the network latency. What I meant by the inference is when the model is given some data-driven decisions. So let's have an overview of the concepts. What exactly is machine learning? Because the core of this talk is built upon what is machine learning, and we'll be building machine learning model from the scratch. So AI is, in a nutshell, a bigger umbrella under which machine learning and the deep learning comes in. Machine learning is basically when you're training the models on a labeled data set, and the model is learning from that labeled data set in order to give some predictions. Deep learning is a subset of the machine learning, which is going one step ahead, in which it is extracting the patterns from the data, and then it is performing whatever the algorithms or the mathematical computations in order to give you some data-driven decisions. The example shown over here is the handwriting recognition for the deep learning. And spam email detection is the example which is given here for the machine learning. Given that you have labeled emails data set, and you need to determine whether the email is a spam versus not. So what you will do, your model will learn the patterns slash it will, you are also explicitly programming your ML algorithm. Okay, this is the data set, these are the features. Now apply this algorithm and let me know whether that email is a spam versus not. So far, we have covered a lot of theory. Now I want to test. I just want you to take a minute and think. Think which of these faces are real. The face A with the women and something in the background. Can't justify exactly what it is in the background, but yes, there is something. Or the face, please raise the hand if you think it's a face A. Okay. Nearly 5% of the people in the audience. Please raise the hand if you think it's a face B, which is the real one. Okay. I see approximately 50% of the people. Okay. Please raise the hand if you think it's a face C, which is a real face. Okay. There you go. Okay, sure. Well, the news is none of these faces are real. This is an application of the generative modeling. Unfortunately, none of these people exist, at least on the planet Earth. I can't talk about the extraterrestrial planets, but of course. So the generative modeling, what happens in the generative modeling is you are given the human faces data set, which is publicly available, and then you are training on those publicly available data set. So to synthesize data set which looks very much similar to what it actually exists, like in the real world. So generative modeling, or you can say deep generative AI, it's a very powerful and it's a very complex idea. For example, OpenAI has also released the ChatGPT. It's a generative AI application. DALL-E is also released by the OpenAI. These are all generative AI models. Okay, so we know about all these generative AI modeling and about the AI algorithms, but what is exactly the underlying building blocks behind these algorithms? And that's where neural network comes into the picture. So that's the basic neural network structure. It's the building blocks behind all the algorithms that you can think about in the AI space. So what this exact structure implies is, given a data set as an input, you are applying machine learning algorithms. At the moment, just understand machine learning nothing but as a black box, which has weights, sum and bias, and activation function. And then you are finding the output. Output is nothing but which you have already predefined. Well, maybe I want to do some image classification, or maybe I want to do some spam email detection, something else. These are certain examples. Let's understand this basic neural network structure through an example to get more clarity. So here, the use case that I'm trying to identify or I'm trying to work on is, given an image, you need to determine whether this image, which category or animal category that image belongs to. So right now, your system doesn't know which image it is. So you are just providing a blank image, the image of a cat, which we can visualize right now. And so the system will understand it nothing but not as an image, but a combination of zeros and ones. And then you apply machine learning algorithms on top of it, which is what we saw in the last slide, that you are applying weight, sum, and bias and activation function. And then it will give you the output with certain accuracy or certain confidence interval, as what you can say. So now it states, after applying image classification algorithms, it is telling, with 82% accuracy, this image is of cat. Let's understand and let's also implement this image recognition using existing libraries in the JavaScript. But before that, let's also cover what are the principles behind it. So the very important and the crucial question next I want to solve is, can we really develop machine learning models in browser / on device? Well, the answer is definitely yes. There are a bunch of techniques that we can adopt and we can deploy or / build the models. First is using the quantization technique. What I meant by quantization, it's nothing but an optimization technique. Basically, it reduces the precision of the numbers which is being taken by your model's parameter. Quantization is significant. It's very much useful because it significantly reduces the memory and the compute requirements by your model, and therefore people generally adopt quantization techniques. Again, we already know that specialized hardwares are available, so we can definitely use specialized hardwares like the GPUs or the TPUs in order to build machine learning models on the edge devices. Because we know that machine learning models are very much compute intensive, and of course we need like strong hardware. And also a lot of applications, a lot of Android and like a lot of cell phones, they do have the GPUs and the TPUs inbuilt right now. So we can definitely build models on using those accelerated, or I would say hardware features. Next, and the most important, is using in-browser machine learning frameworks like the Tensorflow.js, Onnx.js, or Core ML. Core ML is definitely useful for when we are building any machine learning application on the iOS devices as well. So let's see a demo. Okay. So right now, what I'm trying, so I have already the template code ready with me. I have already imported the Onnx.js as one such library. The use case that I'm trying to solve right now is here. Given an image, I need to detect what all features or slash what this image comprises about. There could be like some people in that image. There could be a like something features will be there in the image. So the model needs to determine which particular entity, I would say, it belongs to. So again, over here, right now I've defined a constant, that's a model name. And here I will just write the model that I'm trying to use. Here I'm defining the input parameters, or slash, I would say, the dimensions of the input. Top K implies the top features that I want. And again, I can define the threshold values. Here I'm trying to define the tensor, which is the basic building block behind all these neural network. And how I'm going to do it, I'm calling this tensor function and passing in the float, which is float parameter. And next, here I'll be applying the quantization technique, because I want to give a live demo about how we can apply the quantization technique. Creating a float 32 array and then passing it input data, model input shape, and then using the reduce function. Well, never anticipated this, but it's good. Maybe we need to train the models to do the fall of this alarm detection. Maybe, I don't know. Let me try it. Okay, so here I am just passing in the model input shape. Yeah, just a second. So again, definitely live demos are not the right approach for me. Okay. But of course, as a developer, we are meant to build, break, and develop, I guess. Okay. Just a second, maybe. I do have the template code ready though, but I can still do it. Yeah, there is a parentheses, I know, which is missing. Okay. Yeah. Yes. Okay. 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 Oh, wait, it will not work. Because we need to define the tensor. Since we have defined the tensor, we need to use it as well. Okay. Wow. I never anticipated. It's good. Okay. So I defined the tensor, and of course, in the config, which was already defined before, I'm passing it in the YOLO v5, which is an image recognition model that I'm using. Okay, it needs to be the full screen. Yes, it's going to work. I'm not going to disappoint any one of you. Okay, so it's loading image recognition model. Okay. Well, I'm talking about latency, but I'm not incorporating latency in my model itself. Come on. Oh. Value never used. We used it. Oh yeah, I saved it, I think. Oh, thank you. Oh my gosh. What? Yeah. Okay, finally. Welcome to React Miami, everyone. Okay, now it's time for a quick test. Let's see whether it actually works. Definitely should work. Okay, cool. So we can see that using the image recognition model, it is identifying whether this image has an entity of the chair, which definitely does have, and also different people out here, and also the TV. And there is also like a backpack, which you can see in. So it creates basically the bounding box. So bounding box means whenever you need to identify what entities are there in your image, it creates a bounding box for every specific type of an image. I can also try for some other. Let's see. Image. Oh, what's happening? Okay, cool. So I'm not embarrassed anymore. Cool. So here you can see that the backpack, people, traffic signal, traffic light actually. So that's how it shows, it creates a bounding box, identifies which particular entities are there in an image. So that's a very basic example. Okay, now, come on. Okay, let me move on to the slides again. Okay. So we can do the same thing on the Android application, and that QR code on that side, you can access this code afterwards. It's available on my GitHub as well as the slides are available, so you can refer it for your future reference. Next up is let's build your own machine learning model. So the use case that I'm trying to solve right now is given a sentence, you need to identify to what sentiment that sentence belongs to. What I meant by the sentiment is whether it's a positive, it's a negative, / it's a neutral sentence. So let me give you an example. I am super excited to be presenting here at React Miami conference, and especially thankful to Michelle and the other organizers of the React Miami conference. So that's a positive sentiment, right? And the other sentence could be, I don't like pineapple on the pizza. So that's a negative sentiment. So the first thing that you need to do is install whichever libraries that you're trying to use. Either it could be the Tensorflow.js, or either it could be the Onnx.js or / other libraries, ML framework libraries that you can use. Next is you need to define your model. What I meant by defining your model is you need to create an architecture of the model. So firstly, we'll provide what is the input dimension of the input that you're trying to, the input that you will be feeding in. Then you need to define how many layers the model will have. And then further on towards doing the evaluation, which metrics you will use to define, how will you evaluate your predictions made by the model. Here I'm using the metric as an accuracy. So once we have created this model, now it's time to train the model. But before training the model, it's important to divide your data set into, like training, testing, and the validation. So what I meant by training, testing, and validation is, so there will be some, in the entire data set, there will be some part of the data set which your model will use to train and learn from. And then there will be some part of the data set on which your model will be tested / how much prediction it is, with what confidence that prediction it is giving. And the validation is used for when you want to fine tune the hyperparameters. So here I'm defining epochs as the 10. What I meant by the epochs is number of iterations your model will take to learn from the training data set, and validation split something like 80-20 or 80-10-10. If you divide the data set into 80% will be like for the training, 10% for the testing, and 10% for the validation. So that's what I've defined here. And then so you call this model train model. And the next is you use the prediction. Now here we are defining the predictions. Once we have trained the model, and we create this async function in which we are passing the model. 3 parameters that we are passing. First is a model, which we created in the previous slide, the architecture when we define. The tokenizer, basically splitting the sentence into certain tokens, and the text on which you want to make a prediction. And then it will give you the predictions toward data.is, like data, sync function, and then it just gives you the prediction in that case. These are the 4 stages that you need. Of course, installation of library, training the model, and of course, defining the architecture of the model, and then making the predictions. Okay, so the next crucial question is, what are the potential applications of the ML on edge devices? I have not included the exhaustive list, but these are a couple of the applications which are possible and will give you, the idea of infinite applications which are possible. First is recommendation system, that you're getting the notification on your cell phone / on your device that, oh, this is particular genre of the movie that you might like or maybe have seen before. So it's kind of a user-centric personalized recommendation system. In the patient monitoring system, for example, you already use the smartwatches, right? So the inbuilt technology behind is when the doctors can actually assist their patients which are remotely and can assist in their healthcare. Predictive maintenance is definitely useful for the energy and the transport sector if you want to detect the power outages or if there are some outdated equipments. Next crucial question is, after all the rosy picture, these are the benefits of machine learning, these are the applications which are possible, but what exact challenges that we can face? So let's see that. First is memory constraint. We know that the edge devices have a limited memory storage, and machine learning models are compute intensive. So, you can't train from the very scratch bulky machine learning model. What I meant by bulky models are the models which are trained on billions of parameters. Like ChatGPT is trained on billions of parameters. So we can't do that. We can't train the models from scratch on the edge devices for sure. Of course, we need these specialized hardware in that case. So data quality is the next challenge. If the edge devices are producing low quality or / noisy data, so AI algorithms in a nutshell will not work, and it just kills our purpose, because AI algorithms does require a lot of good quality of data set. And again, limited computation resources is because it's the same thread which is linked to the first one, memory constraint, that you need a lot of specialized hardware / you need some frameworks which are already prevalent in the machine learning that you can use for the building the models on the edge devices. Next crucial question is, what are the best practices that we can follow to build / deploy, in a nutshell, bulky machine learning models on the edge devices? So these are some of the best practices which I have adopted and I also use in my day-to-day work. So first is optimize your model's runtime using the quantization pruning techniques. Quantization example, I've already shown it to you. Pruning, or maybe like knowledge distillation. In knowledge distillation, you have the bulky models. You can just distill the knowledge into smaller models that you can run on your edge devices. And finding the right parameters for your inference, be it the batch size, be it the epochs. What I meant by epochs, again, the iterations. For example, your model is giving 97% accuracy in 5 epochs. Then why do you want to train it for 50 epochs? So in that case, you need to think through, or maybe just do some hyperparameter tuning, wherein you are just playing hard or just, like trying and testing out different parameters which are providing into the model. Benchmark. Next one, benchmark in the sense implies that, benchmark your model or your end-to-end application to figure out if there are any bottlenecks. It could be the data processing stage, it could be data loading stage. It's just not only the inference stage, but there are various stages when you are building machine learning pipelines. So you can benchmark every stage in order to find if there are any bottlenecks that you can improvise. Next is use the concurrent or the multiple processes / threads to revamp your code. Again, it's linked with the code optimization the best you can. Again, the better your model and the faster it will give the prediction / the real-time data-driven decisions. Again, so next one is the frameworks. When I say the mobile-friendly frameworks, it's the PyTorch Lite or the Tensorflow Lite, and the example that I gave before as well. So, there is no point in reinventing the wheel when we already have the frameworks in hand. So we can, of course, fine tune based upon our use case that we are trying to solve. And like just feed into the data set that we are trying to plug and play with. The last and the most important is reusing. When I say the reusing, it's reusing about the data. For example, you have trained the model on a task 1, and that task 1 could be a speech recognition, that task that you're trying to achieve. Then you can use the same data set to achieve the goal for the task 2. This concept is the transfer learning. So you can adopt, like some of these techniques in order to deploy or just reuse and just avoid some of the heavy computations that your model might require. These are a bunch of resources for your future reference. And that's all I have for you today. Thank you so much, everyone.